Uh, With the permission of Principal Sir and Head of the Department, Hirekhan Sir, we are now starting this particular program. Hirekhan Sir, I'll start now. Good evening, everyone. I welcome you all for this FDP on Advanced Perspectives in IoT. It is not just fundamentals of IoT, it is something beyond that, covering various associated aspects around IoT. Hence the name Advanced Perspectives in the IoT. Is my voice audible? Yes, okay. Thank you so
Yes,
much for
yes, ma'am. Yes,
messaging
ma'am.
me. Okay. I welcome you all for this FDP.
मॅम व्हॉइस थोडंसं वाढवा.
Okay. Now is it okay?
येस मॅम.
Yes, thank you so much. Let's start again. So I welcome you all for this particular FDP. I'm very happy to share the enormous response for this FDP. Actually, with the tight schedule and heavily loaded days, I wonder how to adjust the responsibilities so that we can attain the FDPs. But once there is a clarity of the goals, in general, the goals for FDP, it is easy to adjust the responsibilities and to attain the FDPs, of course, which is beyond the comfort zones, like you all who have participated. So typically, what do we expect out of the FDP? In general, we join the FDP to update our domain knowledge, to get exposure to the modern trends, to enhance the teaching effectiveness, and ultimately it leads to the professional growth. So I think the same is the thought process of all the participants over here. And hence, you have joined in a large number. That's really great. And I appreciate your participation and welcome you all again. As we have listed the goals just now, naturally, the latest areas are to be explored through such FDPs. Hence, we are here to attend the sessions on advanced perspectives in Internet of Things. So today we have here with us Head of the Department Dr. Hirekhan Sir, Principal of the Institute Dr. Dambhare Sir, and Honorable respected board member Prasad Kokri sir, and today's resource persons Dr. Bhatane and Dr. Sandhya madam. I welcome you all along with all the participants who have joined here for day 1, session 1. Now to inaugurate this session, let us start for this FDP. I request Hirekhan sir to share the preamble of this FDP. Hirekhan sir, over to you.
Yes. Good evening to all. Myself, Dr. S.R. Hirekhan, Head, Department of Electronics and Telecommunication, Government College of Engineering, Aurangabad. It gives me great pleasure to welcome you all, the participants, for this ATAL FDP on Advanced Perspectives in IoT at Government College of Engineering, Aurangabad, Chh.Sambhajinagar, Maharashtra. Government Engineering College, Aurangabad is a premier institution in the state of Maharashtra, established in the year 1960. And the Department of Electronics and Telecommunication is established in the year 1986. This has a undergraduate program, BTech in Electronics, MTech in Electronics with an intake of 18, and a PhD in Electronics. This is a recognized QIP center, as well as the ADF and NDF candidates are working for research in the department. This is an NBA accredited department in succession, and the department has been also granted the Center of Excellence in Thinking System for signal and image processing by the government of Maharashtra. So this particular faculty development program has been organized by the Department of Electronics and the Center of Excellence in Thinking System for Signal and Image Processing. The department also runs the minor program in IoT, Internet of Things. So under NAP, this is a 14 credit available where the 4 courses are studied right from the 3rd semester, 4th, 5th, and 6th semester. And around 4 to 5 faculty members are working in the field of IoT. And thereby, this was a thought in the department to organize a program in the field of Internet of Things on the advanced perspectives in IoT. As it is known, the Internet of Things, all the devices which are connected on the internet, these are things. And by the end of the year 2025, around 27 billion things are connected on the internet. And it is expected that by the end of the year 2034, around 40 billion things will be connected on the internet. So the field of IoT is growing day by day, and many more facets will be unfolded in the due course of time. As it is known, the various aspects under IoT will be covered in the current faculty development program, including the IoT software platforms, the reconfigurable industrial IoT architectures, the implementation of IoT with inferences in intelligent data analytics, then federated learning for IoT networks, then IoT gateway design and developments, and design of IoT system, end-to-end design platforms will be discussed. The resource persons which are available for this particular FDP are from the premier institutions such as IIT, from reputed multinational industries, as well as the overseas experts will be available throughout these particular sessions to explain and guide us the current state of affairs in the field of IoT. So with this brief introduction, I would wish all the participants of happy learning during the course of these 6 days online FDP. And as it is on Zoom, all should be comfortable in availing the facilities under this particular online platform. And as it is well known that the attendance in all the sessions must be 80% minimum, as well as tests shall be conducted on the platform, and the score in the test should also be more than 70%. So I hope that all the participants will enjoy these sessions and will take care of the attendance and the learning activities here. All the best. Thanks.
Thank you, sir. Thank you for the elaborate introduction of the FDP. You have also covered the point related to, rules for attendance and also the test at the end of the program. So participants are well aware of all these things now. Thank you so much, Hirekand sir. Now I request Principal sir to address the program.
Yeah, good evening to one and all. Welcome to this AICTE ATAL FDP on advanced perspective in IoT, jointly organized by Department of Electronics and Telecommunications, and also a very young Center of Excellence in Thinking System. Honorable Board Member Shri Prasad Kukri sir, Professor Hirekand, Head of the Department, Madam Ratna Parkhe, and all the faculty of the department, and more importantly, all the participants which has accepted this particular announcement in a big way. Thank you for that acceptance. Welcome once again. As Professor Hirekan said, this is 1960s institutions, premier institutions of government of Maharashtra, and this department is very vibrant and very well connected with the industry, running UG, PG, PhD program, and also contributing in solving some problems of AI domain with the establishment of Center of Excellence in thinking system. This is also a very strong department in terms of the NEP implementation, holistic development of the students, and the professional bodies activities. So thanks to the entire department, Professor Hirekan and his team. As Professor Hirekan said, there are billions and trillions devices are connected and will be connected to the internet, and these all devices will be smart devices, will be developing, generating a lot of data, and this is very vibrant field. Even the experts cannot forecast where this technology will go and how it will impact every aspect of the society and human being. And in that context, the title of the program is very well articulated. It is asking for the advanced perspective in IoT, double IT, and AI-based IoT and all. Dear friends, data is important in today's world. I need not say, but what to do with that data, how to store that data, how to make the data analytic of it, how to visualize that data, how to use some effective tools, effective AI tools to derive the useful informations of that data, and finally, how to make use of this technology for the humanity, for the society, and that is important things to discuss. We being the developing country, and lot of things are yet to automate. Automation has not reached to the last person of the society, and we being the technocrat and the technical person, it is more responsibility on us to develop the applications which will be useful, which will have a positive impact on the society, and that too with a very minimum cost, very low cost. Okay. Okay. And the another part of it, I would like to say that we all are talking of NEP implementations, and when we say of NEP implementations, we wanted to develop the manpower, the human beings which will be useful to the society in every sense, and where their all around development will forecast. So it is also important for the technological people that can we deploy more such courses for the non-engineering branches, including arts and other aspects, on other aspects. I am very happy that in this particular course, there are enough sessions of industry expert and also the international expert, which will certainly bring the industry exposure and international exposure to all the participants. There are, I hope, 13 sessions of 1.5 hour duration for 6 days. So very well thought and very well articulated program. So I must congratulate the organizing team. And ठीक है ना कि so I will also suggest that this will be, I'm sure that this will, all the participants will take this particular course beyond the certification, where the joyful learning will happen, and everybody just think of the project that we can deploy to our institutions, and interdisciplinary project is the important need of today's industry and today's society. So in that context, I will be happy if the course will be taken beyond certifications, where the interdisciplinary project, interdisciplinary groups will be formed, and the IoT development will go in that respect, in that direction. Anyway, I will be brief. Once again, I congratulate the department, and more importantly, I congratulate all the participants which have registered for this particular course. And this course is online. We will certainly welcome you whenever you are visiting this part of the state, this part of the country. It's very rich in heritage. IKS was at its top in this particular region, particularly in civil engineering, which the Ajanta and Ellora demonstrate. So, if you are visiting this particular part of the country, please do give us a call. We will welcome you on the campus, and this our association will begin from this particular course. It will not be only limited to the certifications, but the associations will grow, and in years to come, we will take these associations further. So, with this short note, I again congratulate the organizing committee as well as the participant. Wish you a very joyful, very enjoyable, very learners centric FDP. Thank you very much.
Thank you, sir. Now, at the end of this inauguration session, Kokri sir and Principal sir, please accept our thanks. Firstly, for permitting the conduction and organization of this AICTE FDP, and secondly, for remaining present and guiding us in the inauguration of this FDP. Thank you so much. Now let us start the session 1, day 1. I hope we could catch the timeline. So though we started a bit delayed, but we are now in the right track and right time. So let me just introduce today's first resource person, and then we will hand over the setup to resource person. He is Dr. Bhatane. He is from the Mechatronics Engineering Department, having teaching experience of more than 20 years. His research area is solar energy. He has conducted so many courses on IoT, WSN, broadband communication, satellite communication, control engineering, optical fiber communication. So he has a diversified, knowledge to share with us, and he can guide us on the topic today: challenges and applications of IoT. He has many publications at his credit. He has also fetched the grant from AICTE, 10 lakhs rupees he could fetch from AICTE in the mod drops. Then he has delivered several guest lectures. He has also attended 20 plus FDPs like this. So with this brief introduction, Dr. Bhatane sir, please start your session.
Thank you, ma'am.
Yes, thank you.
Respected Principal Sir, Dr. Dambare Sir, respected Head of the Department, Dr. Hirekhan Sir, respected Dr. Ratnaparkhe Ma'am, respected Dr. Prasad Kokil Sir, and Dr. Sharma Sir. I'm very thankful to all for giving me this opportunity. This FDP, sponsored by AICTE ATAL, Advanced Perspectives in IoT. My topic is IoT applications and challenges. I am Professor J. Bhatane, Sanjuni College of Engineering, Kopargaon. IoT, Internet of Things. In the IoT, different types of things are connected to the internet. Things means all types of objects or living or the non-living things are connected to the internet. And internet is available worldwide. So tremendous applications of IoTs are there. If we combine this IoT with the artificial intelligence, machine learning, then blockchain, so advanced applications are there. IoT, Internet of Things, this term is invented by the Kevin Ashton. IoT is considered as a device on the internet, and all these devices with the sensors having IP address are connected to the internet. And in the IoT, basically there are the three layers. First is the physical layer, that is called as the perception layer. Second is the network layer, and third is called as the application layer. Basically, the sensors collect the information or the data. Basically, two types of sensors are there: analog sensors and digital sensors, whose output is analog and whose output is digital. Mostly, we have to prefer the digital sensors, because if we go for the analog, there are some of the drawbacks of the analog signals. Means noise will be there, then we cannot save the information or the data, signal processing will be there. So because of that, then hardware will be increased. So because most of our processors are digital processors, so we require again analog to digital converter. So because of that, when for going any IoT application, we have to always prefer the digital sensors to reduce the hardware and as well as to reduce the cost. Then in the IoT, this is the one of the type of network. In this, anything is connected to the network, then any places, any services, and any networks. So these are the specialties of the IoT. There are the different definitions for the IoT in different words. Suppose it is a infrastructure of interconnected objects, peoples, systems, and information resources, and process the information of the physical and the virtual world and to react. Maybe this is the framework in which all things have a representation and a presence in the internet. Then IoT offering bridging the physical and virtual worlds. Then it is a network of physical objects, people call things that are embedded with software, electronic network, and sensors, which allows these objects to the collect and exchange data. So there are the number of definitions of the IoT, but main thing is that in the IoT, all the things in the things, objects will be there, then humans will be there, machines will be there, all will be connected to the internet, and there is the hardware and software configuration. In the IoT, there are the H's and C's. So what are these H's and what are these C's? So H means any device
you can connect, anything you can connect, anywhere you can connect, any network you can connect, any context means any type of situation you can connect, and any business you can connect. And since means what, in this computing is there, data computing is there, in the network connectivity is there, sensors data to the network will be there, then collection of the information of the data will be there, and convergence will be there. So all these A's and C's are in the IoT. IoT is the combination of three visions. So first vision is suppose things oriented vision. In things oriented vision, suppose things means objects. So here RFID will be there, NFC will be there, then sensor will be there, smart objects will be there, then things communication will be there, and IP for smart devices will be there. Then second region will be there, or vision will be there, oriented vision will be there. In this, adapt networks will be there, web of things will be there, WT will be there, and third vision is the semantic oriented vision is there. So in this, AI technologies will be there, learning technologies will be there, and reasoning over data will be there. And when all these three visions, means which things oriented vision, internet oriented vision, and semantic oriented vision, when combined together, there will be the IoT smart semantic middleware. So here one term is there, smart objects. What happen in normally, sensors are there, they only collect the information or the data, but when there are the smart objects, so that smart objects contain themselves battery, then small processing unit, memory. So because of that, what happen in the IoT, most of the data is collected and sent to the cloud through the network. But when IoT is collecting the data, in that most of the data is unwanted data, and very few data is wanted data, or which will be useful for the next application. So because of that, what happened in the smart objects, most of the processing will be done at the node level, and only selected data will be sent to the network in the smart objects. So in the IoT, Internet of Things, these are the some specialties: anytime, any context, anyone, anybody, any service, any business, any path, any network, any place, anywhere, anything, any device. So this here.
Is it visible, ma'am, my screen?
Madam, yes.
Yeah.
Okay, I will introduce the next speaker. She is Dr. Sandhya. Her teaching areas are analog electronics, antennas, and electromagnetics. Her research interests are variable antennas, electromagnetic band gap and defected ground structures, DGS and EBG. She is PhD from NIT Warangal. She has published many papers in journals, and she has also published many papers in conferences. And she is having IEEE, microwave theory, and many other society memberships at her credit. So I guess I will hand over the setup to Sandhya madam now.
CAD tool, kind of Tinkercad. Also, we can make it like few devices we can combine, and we can make it something like a smart app using some software interfaces, something like Blink or ThinkSpeak. Like this, lot many softwares are available to us. So using those softwares, we're going to interface today using Arduino IDE board, and especially ESP32 board. I think in the previous presentation, people are asking whether internet connection is needed or not. Like this, some discussion has happened. That is all completely depends on what application that you are working. Because if I say interfacing with LED, I'm using the simulation environment is only to switch on or off an LED. So does on off LED, does it actually requires any GPS connection or Wi-Fi connection? Usually such type of devices is not required na, for that simply on and off, only one button needed, one switch needed. So no such GPS connections required. So there are two popular boards. One board is Arduino Uno board and another board is ESP32. Here comes that major difference, because this Arduino Uno board itself is coming up with without having any Wi-Fi connection on board. Inbuilt there is no Wi-Fi connection. But if we are using the same Arduino board for sensing or for kind of using any home automation applications, or sensing the moisture level in the soil, or some different applications where it is need to fetch any data from its environment, and we need to process the data. Based on the data, we need to take some decision, like whether actually the soil is wet or not, or whether the LED is blinking or not. If you able to communicate the same thing to the end user, then only that Wi-Fi connection and all is required. But for a simple basic operation, that Wi-Fi connection are not really is important, while if I'm operating an LED or a buzzer or something like that. So in a simple Arduino board, if you wanted any such kind of Wi-Fi or any Bluetooth connections, you have to give it externally. So later on, people thought, why not it will be built in any Wi-Fi thing inside Arduino board. Such an initiative is nothing but such an initiative taken by Espressif company. So they come up with a new board, kind of Arduino Uno board. That board we call it as an ESP8266, ESP8266 family we used to say. So in the ESP8266 family, one of the popular board is ESP32. So most of the time we'll use ESP32, so which will come up with the inbuilt Wi-Fi. So if I am using the same LED with ESP32, then there will be a specification. Even if I am using Wi-Fi, we need to mention what is the username of that Wi-Fi, and of course what is the password of that Wi-Fi. All these things we used to mention there, and whichever the Wi-Fi that we are using, for that it will send some SSID, or we can say that IP address. So for that IP address, it will send one link. Through that link we can operate, we may switch on, switch off if we receive the link from the ESP32 board. So these are the two boards. I think I'm very clear. So later on, not only with LED, so I'm also going to show you how it is going to integrated with a buzzer or any LCD if I wanted to display any such text or something like that. Yeah. And again, I've already mentioned, if at all we have these all hardwares, we can integrate it. Very easy to integrate once we have done the programming with any of the board, whether it is Arduino board or ESP32 board. But if you don't have any of the hardwares with us, then how can we visualize the same thing? So there are some online platforms there. The first and foremost one is the Workwe online platform. I think most of the people are aware of this Workwe platform. If not, I will show you in my presentation. So first I'll introduce this Arduino IDE environment, and then we'll see the same thing. If we don't, because we don't have any hardware component right now, but in the end of the presentation, I can show you a simple project that was implemented by me with my students. So I'll show you that project in Workwe online platform, also in Tinkercad, also in Blinkit. How do we visualize the same thing in the form of a dashboard? Means if I add any LED, likewise fan, or likewise any of the appliances that is there in our home, how can we create the same icon in the dashboard? And through that dashboard, how can we operate? Whether if any person is not there in the room, so we wanted to switch off that light. So using that dashboard, simply if it is blinking, it is showing the LED, though there is no person in the room, but still the LED is means the light is switched on. So you can see that, you can verify once, because it is keep on sending you the data. Because if it didn't detect any person in the room, it will mention you, so there are no objects are moving inside the room, so better to switch off the light. If you give the programming in that way, then it automatically, without giving any notifications or any human intervention, it directly switch off that line or that light or fan. So in that way, this IoT is very useful. So we're going to see all these things right now. So before going to that, anyways, Batani sir already given this, because I wanted to introduce this, because I need to introduce the Arduino Uno board. So why each and every such kind of pins are required, all these things, and how we going to connect any such kind of sensors or actuators, any things, how do we connect with the hardware, and the same thing, if we implement any programming, how we integrate. So to know that, we need to know what is that internet. So it is very common term, internet. In any way, So in the worldwide network or internet of computer networks, we can say all interconnected computer networks which are based on the standard communication protocols. So what are those protocols? It might be any protocol, kind of 802.12.xxx kind of Wi-Fi, WiMAX, anything like IPv4, IPv6. All these are all the protocols. They are connected by means of some communication medium. Let me take a basic example, kind of Bluetooth. So if I'm going to add any device or wanted to communicate with the other device using a Bluetooth, so how I establish this communication model between these two devices? So first, the first device, whichever the source device, that need to ask for the request whether if any with that username with that device, means identification, how it will identify that other device which it wanted to connect. So we need to search in the destination device whichever the host device. For that, that host or source device need is a request. So after receiving the request, this destination device has to acknowledge to that request. So we can say this type of models called request respond models, or sometimes we can say publish subscribe models, or push pull type models, also exclusively pairwise models. Like different types of models will be there, and each and every model there is a different feature coming across. As I said, when once it raised the request, that destination has to acknowledge, yeah, I have received a request from certain device, so we need to acknowledge that device. After the acknowledgement, the same source device has to ask for if any password authentication. So once it will send that identifier, let's say some string of zeros, let's say any kind of password. If it entered the same password that is what is displayed in the source device, then it will say paid. It is already between the two devices, there is a connection, paid is already done. So once it got paid, again from the source device, it is asking for the data frame, asking for data to be sent. So whatever the data that need to be taken from that destination or source, both will exchange that data. Once the data communication has done, then the source device has to raise again, close the communication model, means switch off the Bluetooth, something like this. All this communication will happen between each peer to peer. So the same thing I've explained an end user application here. So if you see the internet cloud, complete internet cloud, we can say some external DNS server, or we can also start with the end user. If I say the end user, sometimes maybe end consuming internet connections are simple personal laptops, or it may be simple mobiles. All these things are connected to simple wireless router in our homes, and all the routers are connected to a modem, means kind of hierarchical network. Means at the router, maximum it can take a load of 5 to 6 devices. After the router, a modem can take such routers. How many such routers it can take? Likewise, how many such modems we can connect to internet? So in this hierarchical manner, all these end users are connected to the total internet cloud. Not only that, if you can see here, SQL server or maybe DHCP server, all these are connected to at one switch. Maybe it is we can call it as a splitting type of switch. Let's say if it is having some 5 to 10 ports, so maximum of 10 devices you can connect at this end, and all such are connected to one of the wireless access point. So we can call them as SPs or WAPs, wireless access points, or maybe station nodes. We can also call station points or station nodes, but these are not called as a router. If it is using for a simple Bluetooth Wi-Fi kind of application in our homes, we can use router switches, something like that. But all these kind of switches will be connected at one wireless access point. All such access points again will be given access to the internet cloud. So from the internet cloud, whichever the information they wanted, first of all that information will need to be sent to this wireless access point. So from the wireless access point, that is why where this actually internet fails, suppose if any one of the node is having any of the problem, or we can say defected node. Let's say if this access point will be defected, so once if it is defected, it means whatever the devices that are connected to this access point, all will lost, though these devices are working correctly, but because of failed at this point, and it is no more connected to the internet cloud, it didn't get any information. It means though the end user is working correctly, but it didn't get any of the information from it. That time we'll ask for the service.
Control L. So what I'm going to talk about today is a cyber physical system. So just like in case of IoT, we have different devices which can be connected over the internet.
and then they can communicate or exchange data over the shared communication medium, that is the internet. Just similar to that, or just an extension of that, what we have is a cyber physical system. So as the name suggests, it's a physical system. So we have physical devices, components connected over a cyber medium. So again, IoT. So it is a system which integrate physical components and maybe our algorithms, data capturing processes to monitor and control various processes. So what we have here in this diagram, we have certain physical interface which is connected to a physical plant. Then we have sensors on one side which are capturing the data. So you can see there are two different blocks. Then we have a software which is processing that this data. So there are three different computation blocks. Okay. So we have two different platforms over here. Platform 1 has got some sensors and computation. Platform 2 has got some other kind of sensor and then some other kind of processes which are performing certain where certain algorithms are running, capturing some useful information from the data, and then based on the communication between these two platforms, some decision is taken. Maybe the task is related with sensing the temperature, and if some temperature is high, then increase the cooling, or if temperature is very low, just monitor the cooling or room temperature. So accordingly, these actuators will get actuated. So they will generate some signal which can be sent to the devices connected to this physical plant, and then based on this, again, further action will be taken. So this is the closed loop system where we are capturing the data from the physical plant, processing it, taking some decision, and then based on that decision, again controlling the process going on in the physical plant. So in this manner, our cyber physical system works. So where there is computation, there is a software, and this software maybe it can be some AI model, machine learning model, deep learning model, or it can be some communication network for communication among different platforms. And all these, like these two platforms, platform 1 and platform 2, they are communicating over the internet or maybe a dedicated network. Okay, so we are going to talk about this particular system, how to study it, how to implement it, and then maybe what are the open challenges in this domain. So moving to the next slide. So today, if we look, we are surrounded by around 75 billion devices capable of transmitting the data over internet, transmitting and receiving. So for an example, if just some idea comes to my mind, even without explicitly mentioning it through written or oral communication, if I have some brain mapping sensor attached and connected over the internet, maybe over Bluetooth to some processor, microprocessor, so I can operate that microprocessor just through my thinking. So just I will translate some signals which are there in my brain wirelessly to my microprocessor or processor and do a dedicated task. For example, if I have to switch on AC available in this room, so I need not press any button, just a thought came to my mind. I have brain mapping device. It is connected to the computer, and even my remote is a smart remote which can communicate with my processor over internet or maybe over Bluetooth. So just transmitting this information over this dedicated setup, I can switch on the button on the remote, I can switch on the AC, or later I can switch off the AC. Okay. Now, the problem with this is we have a huge amount of data. Like Google captures each and every bit of our life. It knows how much I have spent this month, how many medicines I have to take every day, how many steps I walk every day. So, in this case, as Google captures this data, similarly, we have lot of data captured through our actions over every day. Okay. So the velocity at which we capture this data is measured in terms of zettabytes. So zettabytes of data is collected every day. Oh, sorry, every month. Okay. But the problem is around 90% of this data is called as dark data. Why? Because it is collected, but it is never analyzed. So when we are looking at this dark data, storing this data, handling this data may create problem, but we don't know how much information this data has. So data and information both are different things. Our hard disks are full of data. For example, I click picture every day, but I may not be able to see those. Okay, I never see those pictures. So my hard disk may be full of such images or photos captured by me maybe 10 years before. But from information perspective, I don't have any information which can be captured from that data because I'm not at all looking at that data. So analysis of this data, visualization of this data, or finding out useful data out of the available data and then removing unimportant data is a task that we can do. So this data can be collected either by using single devices, just like I have this digital watch with me, or it can be captured through multiple devices connected over the network. So in a case study, I will go through one such example where we have multiple devices connected with each other and together they are collecting the data, then storing it somewhere for further processing, or else we can have an example of various nodes which are capable of sensing temperature, humidity over multiple points in a college premises, and then they are sending such data to a particular data storage unit, and then it can be processed. So currently what we are doing is we are capturing the data through the sensors, then we are storing that data. Okay, we may look at that data through visualization, through some dashboard, and if the processors are online, okay, for example, if I have to switch on ACs inside a chemical reactor based on room temperature, so I have to do certain action. So it's a human action. Okay. Now the problem with this human action is, even though we visualize the data on the dashboard, our reaction time, the time that we take to respond to any action that has happened, is around 250 to 500 milliseconds, which is quite high. Whereas, for example, a high precision robot or a power grid may require that we should respond within 10 milliseconds. Okay. As we are unable to respond in this hard time constraint, system may lead to failure. Okay. So what we want to stop such a failure to happen. So how we should do it? So we can analyze the data, find the pattern, and we can take the corrective action. Okay.
Then convolution operation afterwards, convolution, batch normalization, ReLU. Once we perform this operation, then we will get the output feature map that we call as f of x. Okay, so f is this is transformation kinds of operation. Once we perform this operation, then we will add this identity mapping. And so the main purpose of this identity mapping to solve the gradient vanishing problem, which is generally observed in existing models such as AlexNet, LENet and VGGNet. And because of this identity mapping, ResNet residual network is giving the better results as compared to the existing classification based model. So let's discuss this. In case of residual net, it is considered there are different value of ResNet. So ResNet 18, ResNet 32, ResNet 152. ResNet 18 means it consists of the 18 layer. So in ResNet 152 means it consists of the 152 layer. And this ResNet layer, this residual network is deeper model and is solve the gradient vanishing problem by using the identity mapping that we have already discussed in previous slide. Also, this ResNet achieve the better state of the art accuracy on classification. So IL-SVRC data set, that is ImageNet data set, and top one as compared to the existing models such as AlexNet, VGGNet, LENet. So that's why nowadays people are going to use this ResNet for different kinds of application. So to solve the problem in existing CNN based model, such as convolution neural network or classification based models such as AlexNet, VGGNet and ResNet, researcher has proposed the vision transformer. First they have proposed attention all simple transformer kind of network, and after that researcher use this network for different kinds of application such as language translation, as well as image point of view, and later on we will discuss this point. We will use this model for IoT devices. So, and this attention transformer provide the better long range information, and because of this transformer model extract the context level as well as fine level information from that input image. So let's discuss this paper. So in this case,
Then, if you see today, 2000, at least a millennium generation, internet is everywhere. Though we never studied with internet, but then when we started working, internet is everywhere. So that's what we call as a millennium generation. But this millennium generation is having that internet not only in computers, internet was available on your gadgets, mobile phones or pagers and so on. So wireless communication and those network protocols, everything is in place. But even industry 4.0 is obsolete, outdated now, is a past now. IoT is a past now. What is today we are is this alpha generation. Gen Z is also now is gone. Now, if you see in terms of human generations also, between alpha, Gen Z and the millennium generation, the gap is hardly 10 years, 10 to 5 years, not the 100 years or 150 years. So in 5 to 10 years itself, the industry revolution is happening now. Now today where we are at the humanoids. That means human intelligence. So what do you expect today in 2025, 26? What you expect is that every product, every single product, wherever you see, it should have the human intelligence. That's what is the expectation. The kind of computational power or the mathematics which are running inside the device is at least equivalent to a human brain. So human brain means let's say some 15 years, 18 years child, whatever the database a child can have, 18 years kid, that much database a device should have and should have the ability to process. So this is where we are today. That's another matter of concern, that AI is everywhere, right? That's the industry 5.0. Now, again, this is a buzzword. AI is everywhere means what? Is it the the data center where people are using, right, AI platforms like ChatGPT or Google, Gemini, and so on, right? Now, some more has come. Even India has come up with the Sarvam AI, and there's some DeepSeek, and there are more than 10, 15 popular AI platforms are currently available in the market. Every AI has its own advantage. So there is no, they're developing their expertise. Some of them are maybe good in, for example, Sarvam AI from India, their focus is on Indian languages. And then not only Indian languages, also in terms of the conversion of those scanned data into text form. We call some OCR and so on. So that means the human intelligence is now happening with the help of your data centers, right? Now data centers is not just a data warehousing. Data centers are now having a AI inbuilt, and they are providing the services. All right. So if that is limited to only for expert systems, it is well and good, like weather forecasting and all. No, people for some oil exploration, and where we used to teach about the expert systems. But today, it's not only just for those research applications. Now the AI is everywhere, right? Every part of our human life, we are using AI, like we already experienced ChatGPT and so on. Okay, so now what's the problem here? The problem here is, if you look at like engineering faculty point of view, last 1 year, we are surprised to see that every single experiment what we conduct in the laboratory can be done in 5 to 10 minutes of time. If you are teaching anything related to, let's say, HTML coding or a programming languages or any other technological problem statements, including civil, mechanical, electrical, any engineering problem, if you give it to these AI tools, it is giving a solution. That means even a mathematical expression which used to take at least 1 month, 2 months is happening in 10 to 15 minutes of time. Writing a paper, writing some, your theory and the literature survey and so on, including your experimental results, is happening 10, 15 minutes of time, which used to take at least 3 months to 6 months of time. Now, what is engineering now, right? In engineering subjects, every subject, wherever this technology languages are there, are no more a traditional practicals. The programming languages which we used to teach at least 6 months to 1 year are no more required, because even if you teach any programming language, how much expertise a student can develop? 10%, 20%, 30%, right? No expert in this world can be knowledgeable more than 40%, right? Expert I'm talking. But if you see your generative AI or the agentic AI, whatever these LLMs are coming, they are having 100% knowledge. We are having only limited knowledge. So they are generating without any syntax error. But when our most of the energy goes in only functional verification. Forget about the optimization and the performance. So this is where the problem is. As an engineering subject, even if I don't talk about mechanical, civil, electrical, telecommunication, even if I stick to computer science, as unfortunately 60% is today happening, there also their practicals, the engineering subjects, whatever they are teaching, is no more relevant. This is the reality. Now look at even every day, the companies, right? The companies who are supposed to produce software, supposed to appoint the software engineers. They are saying we don't require any software engineers no more. Every day news, including the company's policies, that particularly code generation, entry-level jobs, no more we require the computer science graduates. So unfortunately, AI is supposed to be a useful tool for expert system, is now most of the times this AI is replacing the engineers in terms of some jobs. All right, so that's the motivation that AI is everywhere, every part of the life.
Thank you. Thank you very much for inviting me to share some of my academic experience related to the key theme of this ATAL FDP. I am very much thankful to Dr. Sanjay Dhambre, Principal, Government College of Engineering, Aurangabad, for requesting me to share some of my experience related to the IoT application within energy system. And I accepted his request, and I'm very glad that here you have so many participants. I believe that these participants will be in a position to learn something from this work. The key topic of this FDP, that is Advanced Perspectives in IoT, is very interesting. And of course, it needs to be integrated not only from the smart energy system point of view, but also from the industry 4 point of view also. Already some of my background have been shared with you. So briefly going to the key lecture, I would like to share some of my academic journey with you. At present, I am working as a full professor in smart grid, sustainable energy system with more focus on renewables and hydrogen. At the University of Agadar, where I am working from last 13 years or more than 13 years, I have been associated with many competitive research projects. And most of the research projects are in the domain of sustainable energy system. But within that domain, we have integrated in almost all projects information communication technology infrastructure. And for that, we have to include the IoT also. Before coming to University of Agadar, Norway, I was working at University College London as a director of program and senior lecturer, where I was responsible for developing multidiscipline School of Energy and Resources for the first offshore campus in Adelaide. During that period, I had the opportunity to work very closely with South Australian government also. And I was also the board member of South Australia government's first renewable energy board, in which we tried to develop the policies in which how we can include the engineering or technical expertise for bringing our sustainable energy systems or making our communities more sustainable. So you might have observed that in South Australia, now almost 80 to 90% annual energy, electrical energy is coming from the renewable energy sources. And most of the houses, they are having building integrated photovoltaic system with energy storage, in which almost in every house, IoT enabled smart meters are integrated. Before coming to University College London, I was working at University of Dundee, Scotland, where I contributed in developing bachelor or master's renewable energy program in a very innovative way. So how the industry can participate or how the working professionals from the industry, they can participate, especially in the master program. And before that, I was working at University of Jyväskylä, Finland as a research director, where I was responsible for developing integrated laboratory of renewable energy system with hydrogen as an energy carrier. And before that, then I was working in Canada at Hydrogen Research Institute. So I will not go in much detail about my academic journey. You can find out my academic journey, academic contributions in Google Scholar also, and ORCID also, and at manywhere. So today's lecture, I'm going to focus on that how IoT based households, IoT based household energy aggregation in smart. And for that, I'm going to share with you some insights from an European Union Framework 7 demonstration project. And the key idea behind this project is that how we can empower our households for making a scalable and including multidiscipline approach for making virtual power plants through demand response. Okay, so
Sir, you are mute. Please unmute yourself. Madhav sir? No, you are still mute. Co-host के लिए.
Okay. Yeah, right. You are able to hear me now?
Yes. Audible.
Okay,
Sir.
okay. So, is my screen visible to everyone?
Yes, but
Okay.
not the power. Yes, we
Yeah,
can see
just
you.
right now. Yeah, I think PowerPoint is also visible. I think
Yes, sir. Yes, slideshow
right.
is also
Yeah,
visible. Please go ahead,
right.
sir. Thank you.
Yeah, thank you. My full name is Madhav Narayan Arotle. I have total 12 year of experience. I started my career in the teaching as an assistant professor. I work in 2 to 3 different colleges. During the teaching, I conducted many workshops for Arduino, Raspberry Pi, and the embedded Linux side. And after that, I started my career with the Parsys Mobile System. Parsys is basically in public bicycle sharing domain. There I work almost 1.5 year, and after that I work in the iLumi solutioning, that is mesh technology. They were controlling their end devices by using the mesh controller, and almost in 1 year, 1.5 year, I worked there. Due to the COVID, again I joined another company as a GeoTesseract, and there I work on the MR and XR technology. And after that, I work in Johnson Control, Eaton, and currently I'm working in the free space workspace fabric company. So my domain is into the IoT, microcontroller firmware development, verification, gateway development, and verification. And thank you, the organizers, providing me opportunity to give the session on IoT gateway product design and development. We are going to start with this session, and with this session, today's agenda is introduction to the IoT gateways. As I said, I am going to provide you the knowledge on the system that I have worked in the different companies, like public bicycle sharing system. I work in the Parsys mobile system there. They were using their own gateways. Another is the mesh tech devices, and I'm going to explain you this whole system, how the use case, how the design is there, how the gateway utilizing the input, and how this overall system is there, and all this system is using the IoT gateway only. And the next is Metasys. Johnson Control, they have the product as a Metasys for the big buildings in the building automation, whereas is in the smaller buildings. And I'm going to explain about this gateway or their architecture, how they have implemented this Metasys. Next is a microgrid controller by the Eaton.
They have the PXMC 3000 and PXMC 5000, and how their system is actually configuring, controlling their microgrid technology. At the end, previously I was working in the mobile technology, Global Logic and Hitachi company. They have their system as a Bill Murray HMAX. Another building automation system is there, and I work on their two gateways. One is a FLC 500, that is for the access control, and IRPGC, that is for the energy meter management. We'll start with the introduction. So you can see, I hope this workshop or this training session is started. Now 1 week is completed. I hope everyone is aware what is gateway. Still, I will give you a brief about the IoT gateway. You can see on the screen these simpler block diagram for the gateway. On the left hand side, we have the web UI, mobile application or HMI system, and from that there are control signals, or whenever user is going to do any kind of any scheduling or any on off, the UI is there, that is been sent to the cloud, and from that cloud the gateway is already registered on that cloud, and that the control signal in terms of JSON is transferred to the gateway. And now this gateway will act as a bridge. It is going to translate the protocol. This from left hand side, you can see the front end, HTML, backend, and cloud. This technology and this protocol is there. That is been transferred to this right hand side. Right hand side, we have the field equipment controllers, and that field equipment controllers connected the sensors and actuators. And these field equipment controllers could be based on the Linux SoC, or could be the based on the microcontrollers, and their protocol, the way they have connected with the sensors and actuators, there are I2C, SPI, or any other interfacing is there. So you can see the left hand side, we have one kind of a technology, one kind of a protocol. On the gateways right hand side, we have the different kind of a technology. So what is the main purpose of gateway? The protocol translation, whatever the left hand side we are interacting, a user is interacting with the web UI or a user interface, that is been translated to this field equipment controller, so they can understand the what control signals is been given to that gateway, and these field equipment controllers will act on that control signal to read the data from the sensors, or the perform some action on the sensors or actuators. That is the gateway.
Good evening, all the participants who are here. Is my voice reaching you?
Yes.
Please reply something in chat box. Is my voice audible? Okay, great.
Yes.
We are here at the end of the FDP. Yes. That's the valedictory session, the last of the FDP. So instead of starting anything, I would love listening. I mean, we all are here. We would love listening feedback from you. Not that feedback link which you have given on FDP portal. Here we are interested in listening from your voice. So is anyone interested? Please let us know by raising the hand or putting your name in the chat box. You will be unmuted by our coordinators. If anyone can share the feedback, please raise the hand or put your name in the chat box.
I have attended all days FDP, ma'am. I'm very much happy and my knowledge is very much upgraded. IoT, because I have taken this subject, means this semester I am handling the IoT only. So only I wanted to upgrade my knowledge. So only I attended this IoT, which I have got very much good impact on this subject, particularly this subject, IoT. This IoT I am handling to the CS students, which they are not happy to take this subject, but I got a knowledge how to interact and how to attract a student for this subject. Futurist subject is this. So I got very much good feedback on this subject, ma'am. Thank you very much.
Thank you, madam.
Thank you. Thanks to all professors, ma'am.
Thank you so much.
Ma'am, one more thing I wanted to tell.
Please.
Ma'am, I have attended a test, but all questions I attended, but 0 marks I got. Is that, what does that mean, ma'am? And feedback also I have given.
We'll check with the portal. See, madam, everything is controlled by AICTE. We didn't do anything. We have just arranged the lectures and the speakers and the Zoom meeting. And that's it, what we have to. We are done.
But so, I have attended, and congratulations, it has came message. But when I seen obtained marks, but it is showing 0. Just
obtained
check
marks
and
0.
Okay. Like that it is showing. It is not possible, no, ma'am. Easy question were there. That all. Means FDP I attended, so I felt easy questions only. So only I'm telling you.
Oh, okay. Let's see,
Just
madam, how AICTE portal will react for that. Even we have to check if we get some control of some of the things.
Yes, ma'am. You just please check it, ma'am. Check it, and because I don't want to waste the certificate, I want certificate, ma'am. It is very valuable certificate, no? So only.
Okay, madam.
Thank you, ma'am. Thank you very much.
The next madam in the line for the feedback, you have showed your interest. Lalita, madam.
Good evening, ma'am.
Yes, madam, please.
Ma'am, overall FDP is very good and very informative. All the sessions, and we also teaching IoT subject to then student also taught many things, and very good all in FDP. Very timely managed and all things is very good. Thank you, ma'am. Okay.
Yes, madam. Thank you. Now, I guess the next madam who showed interest is Rupali Balpande. Madam, please. Rupali Balpande.
I was teaching IoT from last 2-3 semesters, but in your FDP, I got deep insights into the development and organization of IoT networks, and all the sessions were well placed. All the resource persons were having a deep knowledge of the subject, but there was one small issue: the gap between the sessions. At least 5-10 minutes gap, if there was, then it may be more beneficial for the participants to manage all the things. Thank you.
Thank you so much, sir. Now, Suresh Kumar, sir, please check your unmute.
Good evening to one and all. Myself, Dr. Suresh Kumar from Maharishi Markandeya University, Ambala. Excellent session. This semester, currently I am teaching IoT, and the slides were shared perfectly excellent. Monday I attended the lecture when Tuesday I was having lecture. So I used these images also, which were very good compiled, and what we can say that more knowledge is given in short diagrams. That was excellent. All speakers were excellent, ma'am. Thank you very much.
Thank you so much. Do we wait for someone more to share the feedback? Now I'll request Hirekhan sir to sum up the FDP. Sir, please.
Dear participants, Good evening. We are at the conclusion of this 6-day FDP online advanced perspectives in IoT. It was really very enthusiastic for all of us, the coordinating committee, to organize these particular sessions, and the greater inspiration, motivation was that more than 1,000 registrations were available for this particular FDP, and almost more than 500, 600 participation was there for each of the sessions. Obviously, as we are entering in the era of artificial intelligence and Internet of Things being an important ingredient of AI, we all must be aware about, and we all must be in tune with, in step with the changing technology. The IoT is every day is taking up a newer shape in the form of more things, more objects getting connected on the internet, and therefore many more developments are going to be there, and we need to be in line with this, need to understand the newer terminologies, and we have further more scope in having newer studies and implementing those in practice through different prototypes as well as through different protocols also. Obviously, we all being faculty, we have to be in touch with this, not only for updating ourselves, but also training our students, imparting the latest knowledge and skills to our students. So it is really a pleasure for all of us to be with all of you who have joined this particular faculty development program. Though we have not directly communicated with each one of you, I am really happy and thankful to every one of you, everyone here, present here, and those who have registered and attended all the sessions. Obviously, and also the feedback is given by almost 500 plus participants have given the feedback, which is the essential mandatory component of completing the ATAL FDP online sessions. And I appeal other participants also to submit the same on the online portal. For the information of all the participants, I'm happy to state that the attendance mechanism and the test mechanism and the feedback mechanism, these three components for generating the certificate for successful completion of the FDP are all automatic. When the test is complete, the test scores are also generated automatically, and these are from the participant login. So there is no direct control of the coordinators of the FDP on the test. Obviously, the score is already available to the AICTE through the portal as well. The attendance is obtained through Google Forms. So these all Google Forms are available, and everyone can note that what is the attendance in each particular session. That is a record, and accordingly it is available with the AICTE portal also. And feedback everybody has given, and I appeal all the other participants also should fill up the feedback online on the AICTE ATAL portal through your own participant login, so that these processes of generating the certificate shall be completed, because it's a technicality of having the generation of the feedback, generation of the certificate. So those difficulties which you have just stated, I would once again appeal to, because all the records are available and all the records are available on the portal. So definitely if you have any difficulty faced therein, definitely send an email on the given email ID, and we will definitely check it out with the AICTE ATAL portal, because everything is available in the form of the documents. So at the most, it may happen that someone might not have submitted the feedback, and the generation of the test is obviously through the individual login. So maybe some network issue or other things that can be there. Otherwise, from our side, we are all the time have given all the requirements fulfilled there, submitted with the AICTE portal. But still, if any difficulty, please give through the email, and we will definitely check it with the AICTE FDP portal. So it is really a pleasure to have completed this FDP with the participation of all of you in majority, and will definitely being a center of excellence here in the Government Engineering College, Chh.Sambhajinagar. We will be organizing similar academic activities, workshops, and training programs in the times to come. And I invite all of you to join and attend all these programs in future too. So thank you very much for your participation. Thank you.